Hi, my name is Claire Kellner, and our mathematician is John Nash. He was born on June 13th, 1928 in Bluefield, West Virginia, and died May 23rd in 2015. He was named after his father, who was a veteran of World War I. A few years after he was born, his sister was then born, and John Nash grew up in a very loving family, and his mother was very encouraging towards his education, and he did very well in school. His father started to treat him like an adult and gave him science books instead of children's coloring books, and John's teachers did not realize how smart he was or that he had a lot of talent, and so they were more worried about his lack of social skills, and they labeled him as backward. At the age of 12, he showed great interest in scientific experiments at home. He clearly learned a lot more at home than he did in school. At the age of 14, he showed interest in mathematics. He became inspired by a book called Men of Mathematics by E.T. Bell. And in 1941, he went to Bluefield College and took mathematics and science courses as well as studying chemistry. He showed strong abilities in mathematics, and in 1945 he attended the Carnegie Institute of Technology because he received a scholarship, and while he attended there, his interest in mathematics grew, and so he ended up receiving his master's and bachelor's degree in 1948, and 2 years later he received his doctorate at Princeton University. In 1951, he became part of the faculty at the Massachusetts Institute of Technology. This is where he pursued his research, and now Cable is going to share John Nash's mathematical contributions.
Thanks, Claire, and now I'm going to be talking about the mathematical contributions that John made. He had many mathematical contributions, like the Nash-Moser inverse function theorem and the most famous, Nash equilibrium. The Nash embedding theorems were one of the original results in geometric analysis of the 20th century. He made great strides with his work in mathematics. He developed several mathematical concepts. Through his work, he was able to recognize the difference between cooperative and non-cooperative games. The Nash equilibrium is a concept in game theory where the optimal outcome is where there is no incentive for players to deviate from their initial strategy. In the Nash equilibrium, each player's strategy is optimal when considering the decisions of other players. Every player wins because everyone gets the outcome they desire. The Nash equilibrium is often discussed in conjunction with different strategies, which states that the chosen strategy of an actor will lead to better results out of all the possible strategies that can be used, regardless of the strategy that the opponent uses. The Nash equilibrium offers something truly new: the ability to analyze situations of conflict and cooperation and produce predictions about how people will behave. Nash's definition of equilibrium was this: a configuration of strategies such that no player acting on his own can change his strategy to achieve a better outcome for himself. It has gone on to be iterated on and developed to be more accurate and more widely applicable. Today, Nash's concept of equilibrium from strategic games is one of the basic paradigms in social sciences and biology. It is largely the success of his vision that has been responsible for the acceptance of game theory. Like many great scientific ideas, from Newton's theory of gravitation to Darwin's theory of natural selection, Nash's ideas seemed initially too simple to be truly interesting, too narrow to be widely applicable, and later on, so obvious that its discovery by someone was deemed all but inevitable. In fact, it was not even supposed to have any significance for biological theory either. Nash's contributions to mathematics was significant, and we should be appreciative of what he has done now and the future of what it will do for students and educators alike. Now, I'll send it on to Amerie.
Now we're moving on to the significance of John Nash Forbes Jr. contribution to math. So not only was he notable for being a prominent mathematician during the mid-20th century, particularly in the 50s and 60s, but his contributions to math were also important, especially with the contribution to game theory. And this just studies the decision-making in situations where two or more individuals have competing interests, as well as other math-related things like algebraic geometry, differential geometry, and differential equations. So more importantly, just to explain what game theory is, it's just a branch of mathematics that deals with the analysis of strategic interactions among individuals or groups. And although he didn't create it, you might ask, how did John Nash contribute to game theory? Well, with the creation of the Nash equilibrium, he made a significant impact, which is widely used and applied in economics, political science, and other fields. And just to elaborate and define what the Nash equilibrium is, it is defined as the stable state of a system involving the interaction of different participants in which no participant can gain a unilateral change of strategy if strategies of the other remain unchanged. So just to paint an example of this, we can use a classic example of a game John Nash used to illustrate the concept of Nash equilibrium, which is called the prisoner's dilemma. And let's just suppose there are two criminals, A and B, and they're both arrested and held in separate cells. And the police do not have enough evidence to convict them of a serious crime, but they have enough to convict them of a lesser offense, carrying a 1-year prison sentence. The police offer each criminal a deal. If they betray their partner by confessing to the crime and implicating the other partner, they will go free and the other partner will receive a 3-year sentence. If both confess, they will receive a 2-year sentence. If neither confess, they will each receive a 1-year sentence. So just in this game, we can see that each criminal has two possible strategies. They either stay silent or confess. And when the Nash equilibrium occurs, when both criminals confess, since neither can improve their outcome by switching to the other strategy, if A confesses, B is better off confessing since 2 years is better than 3, and the same for the other. And overall, this example illustrates how the Nash equilibrium captures the idea of a stable state in a game where neither player can improve their outcome by changing their strategy, given the strategy of the other player. So I hope you learned a lot about John Forbes Nash Jr.